Okay, so we're going to build out the unit circle here. This is going to kind of give you an idea of how I've memorized the whole unit circle through really just memorizing everything in quadrant one and then using symmetry to flip things around and hopefully give us an advantage on knowing where all the different trig values are evaluated at and at what angles. Okay, so let's start with the first quadrant. So obviously this one here, this is our angle of 0. Okay, so that's our 0 angle. And if I rotate all the way around the circle, I get back to 2 pi. Okay, now this point here, even though it's an angle, I'm going to run out of room, so I want to maybe I'll put my angles on the inside here. Okay, so the point here is 1 comma 0. Okay, so that's the point right there for that first point on the unit circle. This point up here, this point is 0 comma 1. Okay, this value here is negative 1 comma 0, and then this point down here, this is 0 comma negative 1. So those are all the quadrantal points, all right, located on the x and y axes. Now, to do the 3 points in between, okay, so we've got a 30-degree point, we have a 45-degree point, and we have a 60-degree point. Okay, so this is the 30 degrees here. How do we do this? Well, if I draw my triangle, looks something like that. What do I know? If this radius is 1, the shortest side is 1/2, then I got to know the other side here through Pythagorean theorem, square root 3 over 2. And so what does that tell me? That tells me that this point right here, the x value is square root 3 over 2, comma 1/2. Okay? I'm going to delete these 2 points for now, because what I want to do is I want to use the symmetry of the unit circle to get these values going around here. So this angle right here, this theta here, this is 30 degrees, which is pi over 6. Okay? Now, what would go with this? Well, the point opposite over here, what's the only difference? Well, the only difference is instead of the x value being a positive square root 3 over 2, the x value is a negative square root 3 over 2 this way. Okay, so negative square root 3 over 2 this way. Right? And then it goes up. How far? It still goes up the 1/2. Okay, it still goes up the 1/2. So really the only difference is the x value. When we flip this across the y-axis, the x value becomes negative. Okay, so you can use the symmetry there. Well, the question is, what is that angle? Okay, well, what is the angle? So let's think about it. The angle, the full angle would be 180 degrees, right? A straight angle, okay? But it's not 180 degrees. It's not completely that. We lacked off this point here, which we know is pi over 6. So how do I get this angle? Well, a full 180 degrees is pi. So that angle is equal to pi minus pi over 6. Well, what is that equal to? That's equal to 5 pi over 6. Okay? So this angle here is 5 pi over 6 here. All right? Now, for this right here, down here, okay, what's going on here? How is this one related to this one over here? Well, over here I have positive x and positive y. Over here I have a negative x and a negative y. So this point here is negative square root 3 over 2, comma, negative 1/2. Okay? And then this point here, what's going on? I have a negative y value, so I have negative 1/2. But my x value is still a positive x value. So what is it? It's square root 3 over 2. All right, so now we've got, just by getting this one point here, we got 3 more points for free. Okay, so the symmetry here is really helpful. All right, so hopefully that helps you out a little bit. I'm going to knock out some of this stuff. So that we can not have it in our way. Uh-oh, did more than I wanted. Okay. Yeah, we can keep that in there, that's okay. Okay, so this angle here is 5 pi over 6. This angle okay, so that's my positive x and that's my negative x. This angle here is pi over 6. All right, let's do another one. Okay, so what's after pi over 6? This point right here, the 45-degree angle. So the 45-degree angle, we've talked about this one. This is where the x and the y are equal to each other. So this would be 1, and then that would be square root 2 over 2, and this side would be square root 2 over 2. Okay? And so this is the 45-degree angle, pi over 4. Right? So the coordinate is square root 2 over 2, comma, square root 2 over 2. Which ones do we get for free here? Okay, so what do we get for free here? We get the point, okay, reflected across the y-axis. The x value becomes negative, so it's negative square root 2 over 2, comma, square root 2 over 2. Now, what is the value here? Well, what's happening? How are we rotating this, right? We're rotating by an amount of pi over 2, okay? So I have pi over 4 and pi over 2. If I add those together, what am I going to get? Okay, so what am I going to get there? So pi over 2 plus pi over 4, that's going to get me, I guess, 3 pi over 4. Okay, so 3 pi over 4 angle going on right there. Okay. All right. Now what about down here? Okay, it's a negative x and a negative y. So I get negative square root 2 over 2 and then negative square root 2 over 2. Okay. How do I get down to there? Well, what's happening if I start at this terminal angle, right, and I rotate all the way to here, what is that theta? Well, rotating from here to here is pi, okay? But then I have another 45 degrees added in, okay? So that is pi plus pi over 4, which is 5 pi over 4, okay? 5 pi over 4 going on there. Now, let me get rid of that stuff. Okay, and then one last dot over here. What's happening? I have a positive x and a negative y. So this is going to be square root 2 over 2, comma negative square root 2 over 2. Now, what's going on here? Well, there's a couple ways we can go about doing this. Perhaps an easier way is to go in the negative direction with my theta. What do I know? If I go all the way around, that's 2 pi, right? But I didn't want to go all the way around. I wanted to go all the way minus pi over 4, right? So how do I do that? I do 2 pi minus pi over 4. Okay, so 2 pi minus pi over 4, that's 8 pi over 4 minus pi over 4, that's 7 pi over 4 right there. Okay. All right. Let's see here. Okay, I had the angle here for this quadrantal angle. This one is 90 degrees, which is pi over 2. This one is pi. This one is 3 pi over 2. And then that last one going back, it circles around at 2 pi again. Okay? Looks like I missed some of the red ones. I'll come back and do those. So that was off by a pi over 6 factor this way. This is a pi over 6 factor this way. So I do pi plus pi over 6, which I think is 7 pi over 6, right? And then this one, I do the same game that I did to find that. I just need to go in the negative direction, pi over 6. So I'm going to do that. I'm going to do 2 pi minus pi over 6, and I get 11 pi over 6. Okay. All right. One last point to get, and then we'll have them all. We'll do green, why not? So this one here. So once again, that purple one, those were my pi over 4 angles. The last one, the green one here, this is my pi over 3 angle with my pi over 3 angle, the triangle. Looks like this. I have 1/2 for the x value, square root 3 over 2 for the y value, and then 1 for my radius. So 1/2 comma square root 3 over 2. Okay. And so then I'm going to use symmetry to get my other dots. If I reflect it across the y-axis, this becomes negative 1/2 square root 3 over 2. Okay. Down here, it's negative 1/2 and a negative square root 3 over 2. And over here, it's a negative y and a positive x. So that's a 1/2 and then a negative square root 3 over 2. And so now I need to get my angles. All right, so this was pi over 3 here. Okay, so that was pi over 3 there. Then what is this going to be here? Okay, that's going to be another 30 degrees past, so that's 2 pi over 3. Okay, and then down this way here, right? So down that way there, if I have go this way in pi over 3 fashion, that's 2 pi minus pi over 3. That's going to be what? That's 6, that's 5 pi over 3 here, right? And then this last one over here, if you think about it, these are on the opposite sides of each other. To rotate an opposite amount, I add pi to it. So I could add pi to pi over 3. And that's going to get me what? That's going to get me 4 pi over 3 for that one. Okay. All right. So I think that pretty much summarizes up all of the sine and cosine values for each of the different possible exact values you can find. Now, if you know the sines, then you can get the tangents and cotangents and cosecants and secants and all that stuff if you know sine and cosine. So just to give you an example, we'll pick one of them out. Okay, let's just pick this one here, okay? So let's do that one. So what does this tell me? The cosine of 7 pi over 6 is equal to negative square root 3 over 2. And it also tells me that the sine of 7 pi over 6 is equal to negative 1/2. Okay? Remember, this is my x and this is my y value. Okay? So what does that tell me? The tangent of 7 pi over 6, what does this equal? This is going to be equal to what? This is going to be y over x, which is negative 1/2 over negative square root 3 over 2, which negative and a negative make a positive, keep change flip. I get 1 over square root of 3, which is square root of 3 over 3. Okay, so you can run through that game with your cotangent and cosecant and secants, and you can get the other 3 trigonometric function outputs for 7 pi over 6 if you want to at your own leisure. All right, so hopefully this kind of gives you an idea of how to memorize this. What I'm going to do is I'm just going to take this part right here and I'm going to duplicate it. Okay, because really, if you can remember this part here, this is really all you got to remember. Okay, and so how do you remember these values? All right, so the way I think about it, I'll look at the sine values. So the sine of whatever the angle theta is, okay? So when I look at this, right, when I start at sine of 0, so sine of 0, what do I get? Well, the height here at 0 is 0, okay? But as I build up, okay, sine pi over 6, that's the smallest, right? That's the smallest angle right there after. Okay, as I build up, the y values start to increase slowly but surely. This is 1 over the square root of 2, okay? And as I build up further, I keep going up, I get sine of pi over 4. Okay, sine of pi over 4. This is what? This is square root 2 over 2. Okay, I messed up on that first part. This is not 1 over square root of 2. This is 1 over 2. Okay? And then this here, this is sine of pi over 3 for the next build up. Okay? Build it up here. And so what do I get? I get square root 3 over 2. And then the last one, when I come up to here and I go up there, my sine value has built up to its maximum amount of 1. Okay, so the sine of pi over 2, okay? This is technically, this is like square root 4 over 2, which is 2 over 2, which is 1. Okay, so you kind of see a pattern here, you know, of what's going on. So as I build up, and if you wanted to take that out, you could do like square root 0 over 2. You see what's going on here? So when you look at this, as your sine gets more and more, the angle gets bigger and bigger and bigger and bigger and bigger. I'm dividing everything by 2, okay? Everything gets divided by 2. But the first one is square root of 0. The next one's square root of 1, then square root of 2, then square root of 3, then square root of 4. So you kind of see a pattern that might help you out in memorizing what these y values are going to be as they build up. Okay, what's happening to the y's? As I go from 0 to pi over 2, the y value is increasing till we get to the tip top, and then it starts decreasing, and we use symmetry to get those other y values on the other side. Okay, so that's kind of how, you know, I use symmetry to help me, and a little trick that may or may not help you as you try to memorize those different sine values. Okay, and so the same thing works in the reverse for the cosine. Okay, so the cosine, what's happening to my cosine? The x value, as the angle increases, the x value, what's happening? It's getting pulled into 0. So the x value is getting smaller. Okay, so instead of getting bigger like the y value, see the y value is getting bigger. The x value is getting smaller. So what's really happening here? So I have like my sine of 0, which is 0. I've got my sine of pi over 6, which is 1 over 2. I got my sine of pi over 4, which is square root 2 over 2. Look, all I do is I go up from there, right? I think I got them all. Okay, so square root 3 over 2, square root 4 over 2, which is just 1. Okay. Now the cosine of 0, the cosine of pi over 6, the cosine of pi over 4, the cosine of pi over 3, the cosine of pi over 2. Let's think about this. The cosine of 0, where is it at here? It's as far over as it's going to get. It's the 1 value. So that's 1, okay? It's literally the reverse of this right here. So once you get the sign, you just write it in the reverse order. Square root 3 over 2, square root 2 over 2, square root 1 over 2, which is 1/2, and then 0 finally. So it's literally one goes down this way and the other one goes up the other way. And once you have the sines and the cosines, then all you've got to do is use your trigonometry rules to get the tangent, secant, cosecant, cotangents. If you think about it, sine of theta is equal to your y, and cosine of theta is equal to your x for the unit circle. Okay, the unit circle, all right? And so that tells me, you know, tangent theta is just y over x, so you take sine over cosine. Cotangent theta, that's a reciprocal, that's x over y. Secant theta, that's a reciprocal of cosine, 1 over x. And then cotangent theta is a reciprocal of sine. Okay, so I'm going to make this a little smaller so that everything can fit in nicely. 1 over y. Okay? So hopefully this video helps you when you go about trying to memorize the unit circle. You don't have to memorize everything, but you do need to understand this right here, the first quadrant, and then how to flip around, how to do reflections to get the other important values. I can't stress enough how much this pops up in Calculus 1 and Cal 2. Okay, so we use this all the time, probably one of the most important things that you'll need to know coming into Cal 1 and Cal 2 if you're planning to take those courses. Okay, so if there's anything that you need to learn from pre-cal, this is it, guys. This is the most important. Okay.